Now working with numbers. So now this part is useful for us. So we have files with numbers, and how do I work with numbers? So first you need to know file formats. Okay, so you can store that as a text file or ASCII file. Okay, so this ASCII is the format. So I told you ASCII is just every normal characters and English characters or special symbols or take 1 byte. So this is ASCII ASCII format. Binary. So we already know binary. I mean, for integer it's 4 bytes, and for float or real numbers 8 bytes. Now these are special formats called HDF and HDF5. So this is called hierarchical data format. Okay, hierarchical data format. Now, so this is more complex. I mean, it also has some compression. So I don't know inside what happens, but it basically stores in binary, but in a special way. Okay, so HDF and HDF5, these are more sophisticated formats than binary, but you can save as binary and bring out as binary. And there's more, I mean, it's easier to work with HDF5 compared to binary in terms of functions and operations. Okay, in the notes you'll find how to work with binary file, but I don't cover it in today's lecture. So there's some more. There's CSV. CSV format, in fact, Excel sheets are in CSV format. Okay, so you can read and write, and the very nice library called Pandas. Okay, that is used for reading Excel sheets, and in fact, data science, there's huge application of CSV files. So I mean, basically machine learning, data science, they work with CSV a lot. And NASA CDF again. So this CDF. So this is another format which NASA used to use. I mean, now I think a lot of people have moved to HDF5. NetCDF. So there, I mean, people used to create certain format, but presently this is the most popular format for numbers. Python supports it nicely, and we can use it. Now let's see. I'm going to work only with ASCII format and HDF5 format for today's lecture. So we create 2 arrays. So this is nothing to do with files. I just create 2 arrays: x from 0 to 2 pi with a gap of 0.01, and y is sin of x. Okay. So I'm going to try to store it in a file and read from the file. Okay. So let's say we work with ASCII. So what will I do? So I want to, there's 2 arrays, no, x and y. There's numpy arrays. So we can save this on a .npy file. So there's numpy files. Okay, data underscore x .npy. So I store it in this file, and y I store is data y npy. So there will be 2 files. If you look at the directory, there will be 2 files after this operation. So np.save. So it's part of numpy. So it's part of numpy. So this function save. So I save it to these files on the hard disk, and it's stored there. Now you can read it. So we give the file name as argument to np.load. So numpy has a load function, and we can read the contents of a hard disk file and put it on a numpy array. So x read txt is a numpy array. You can just print it also if you like to test, and it will be the same array as before. Same with y. Okay, so there's one way to read and write in a numpy array in ASCII format. So it is converting this number which is stored as a binary to ASCII, but it's putting it back. So there will be some contrast if you are really a number which is not translatable. You can also, Python offers another set of functions for save text. So it's exactly same as this, but instead of save, we have save text. And here the file name is .txt. The txt is not special. I can put that or something, whatever you like. But it is not an NPY. So NPY is a special file, but this txt is not a special file. So we can save as text, and we can load from the hard disk to the memory by load txt. So np.load.txt will do it. So these two are equivalent, basically similar operations. Okay. And if your data is not too big, we can simply work with this load and save, or save text and load text. SD file is slightly more complicated. So, I mean, this is just one line to save, one line to load, which is useful. But if you want HD5, then it will be more work. Okay. So let's look at HD5. So we need to import a module, H5PY. Okay. So this is short form for HD5PY. So import H5PY, and then so this H5PY dot file and the file name and write. So this is, I'm preparing it to write. So my file name is HF. File object is HF. Okay. So I'm all set to write now. So this part is repeating as before. Now, so create a data set. Okay. So there's a comment. So this data set. So I have two arrays, remember, the X and Y. So data equal to X. So you need to write as data equal to X, and it creates a data set called data array X. And so it's creating a data set. Okay, so array X is, the file will know the object name or the array name is array X. X is not, I mean, the file does not know that X is the name of the array. It's array X is the name of the set of numbers. And array Y is array name, I mean, data set name for array Y. Now we can write, close the file. Okay, so it is, it's written already. It's written as array X and array Y. Close it. Okay. So it's more complicated. You see, I mean, you didn't need to create anything. So I just say load, save and load. But here you need to create a file, then create the data sets and close it. And the reading is pretty much similar, just a reverse operation. Okay, so this part of a comment. So you don't need to see. So I'm creating an object called HF2, HF5 file. I'm doing it for read. So array X read is hf2.get. So get is a function. So this is the name of your data set, right? Array X. So it's going to read this array X and put on array X read. And array Y will be read on this array Y read. Now, by the way, I can't print this one, or I cannot plot this one. I need to convert that to NumPy array. So this is another one we have to do. X read is NP array, array X read. So I need to convert this object to read. Now I can plot it. So X read and Y read, I can plot and things like that. Okay, or print it, see the numbers. But this is not yet ready for plotting. Okay. And after that, we close it. So HDF5 is, I mean, you need to remember how to do this. Or remember means you can just look at your notes or a book, and you can just do it. So now we can read an image in Python. Python can do many things. I'm just giving you few samples what are useful for this course. I mean, image we are not going to work with images. So this is just for interest. So matplotlib.image has a function called mpimg. Okay, matplot image. So I take a JPG file, like your picture, no, you take from your camera. So you can take a JPG file and use this function use this module mpimg, and it has a function called imread. So it reads the JPG file, and there's an image. It will create a array called img, NumPy array. Now NumPy array has so image is a 2D array, right? It's a 2D grid. So it will create for each pixel one number, but it stores 3 numbers for each pixel. Okay, so the array size is m comma n comma 3. So m into n into 3, that is array size. Okay, so along x the number of pixels multiplied by number of pixels along y and multiplied by 3. So this is important. Okay, this is important thing to know. You don't need to know like why is im read is im read, why is r not capital. I mean, don't worry about it. You will decide a function name and that is what. But what is important is this 3. So it's a innovation. No, I mean you're not how to store a color of a number of a pixel. So you don't need to store for red some intensity, yellow some intensity, this intensity. You need only 3 primary colors, and using that I can create all sorts of colors. Okay, and this is an innovation. In fact, this is one of the most important innovation for television. Okay, so when television was first, I think it's Thomas Edison's company, which we brought in this this. I don't know which company, but this is a major revolution to bring in this transmission of colors for television. Okay, so we have this object, and of course we can print this thing. So plt.imshow image, and so it prints like this. Okay, so I have taken a picture. This is a picture I took, Amal Das, and this is just a print. Okay, so we can use this for morphing your image, and you can do much more than that, which I don't know how to do it, but you can look it up in Google or books. All right, so this is what I wanted to say regarding files.